Hi everyone. In today's geometry lesson, we're diving into geometric transformations and how they help us understand congruence and symmetry. By the end of this video, you'll be able to identify and perform transformations, recognize symmetrical figures, and determine when two figures are congruent based on corresponding parts. Let's transform the way we think about shapes. Transformation, a rule that moves points on the plane. Function, a rule that assigns exactly one output to each input. Preimage, the original shape or point. Image, the result after the transformation. Rigid transformation or isometry, a transformation that preserves distance and angles, like translations, reflections, rotations. Non-rigid transformation, one that doesn't preserve distance or angles, like stretches or dilations. Let's start with a reflection. Imagine a triangle, ABC, on a coordinate grid. If we reflect it over the y-axis, the new triangle ABC has the same shape and size, just flipped across the y-axis. The distances between points remain the same, and all the angles match. This is an isometry, a transformation that preserves distance and angle, meaning the figure is congruent to its image. Now let's try a sequence of transformations. Suppose you have a quadrilateral, PQRS. First, translate it 5 units right and 3 units up. Then rotate it 90 degrees counterclockwise around the origin. Are PQRS and PQRS congruent? Yes, because translations and rotations are rigid motions. They don't change the shape or size. You can even prove congruence by matching corresponding sides and angles. Think about a video game where a character moves through a symmetrical maze. The reflections of paths ensure the character always sees a mirror image. Designers use symmetry and congruence to create balanced, predictable paths. Transformations allow for these designs to be duplicated and flipped, making the gameplay both challenging and fair. Understanding these ideas isn't just about math class. It's about how our digital and physical environments are built. Let's recap. Transformations like reflections, rotations, and translations preserve size and shape. Symmetry helps identify balanced figures. Congruence comes from applying rigid motions and matching corresponding parts. In our next video, we'll explore how to prove congruence using triangle postulates like SSS, SAS, and ASA. See you there.